position from a restoration agriculture perspective. And tonight we're going to use all of the things that we talked about in previous webinars cumulatively and now start to understand how we interact with our land with these different ecological understandings in mind. And so one of the things that we talked about earlier is that the disturbance of a site, whether it's wind or water, landslides, all that kind of stuff, is what changes and moves this through time. Aside from just the passive growing of all these plants, there's active activity going on that's changing the site, and those activities are the disturbance. Of course, everything is from the perspective is how do we create a permanent agriculture? And my original inspiration for permanent agriculture, permaculture, if you will, is from tree crops, J. Russell Smith. Way massively inspired. My life, I guess, was changed when I read Bill Mollison, and when I heard him say on the Global Gardener video about permaculture design is that the aim is to create systems that are ecologically sound and economically profitable. And what I like about the ecologically sound and economically profitable, if it's ecologically sound, we can't screw up. Everything is recyclable. Everything's part of nature. If it's economically profitable, we can feed ourselves, pay our bills, have surplus to share, and to leverage for other good activities that we might want to do, earth-helping, healing activities. David Holmgren was Bill Mollison's sidekick at first, and he kind of codified what Bill Mollison had started in the Permaculture Designer's Manual. And these are some principles. So we enact our permaculture design on the planet by following these principles. And number one, the one I really harp on a lot, is observe and imitate and interact. We want to observe nature, imitate what works, and then interact with the system that we've created. And that's what understanding ecology is all about. All of the other principles below, from capture, store energy, obtaining yield, and so on, all of these other apply. But first and foremost is if we are not observing nature, imitating nature with our systems, and then interacting with that, we miss the whole point. So that's why we're going through this. And I'm going to bring this up again and again and again until everybody finally gets it. How I approach permaculture, how I approach agriculture, how I approach the production of all these different crops, from pine nuts, apples, hazelnuts, chestnuts, produce, livestock, is radically different than anyone else who has an orchard or a cattle herd or a pig operation, whatever the situation is. A radically different approach. And if we're going to observe nature, we have to actually observe the reality of the phenomena and not just project our thoughts, our concepts, our ideas onto nature. And I want you guys just think for a little bit. If I take apple trees, and we'll see some pictures of this, and I plant a whole bunch of apple trees, and I mow the ground underneath it. Maybe I'll even use some herbicide underneath, so the herbicide strip with no weeds right under the trees. Maybe I'll stake the apple trees to hold them up. Maybe put a deer fence around it to keep the deer out. Here's my apple orchard. Now I spray, X times a week for apple scab, for codling moth, plum curculio, all these bronze-headed borers and various different things. And at the end of the season, I harvest my apples. That's an apple orchard. Well, what actually is happening there, the observable phenomena, is that the person plants these apple trees in the ground and does this herbicide and mows and does the fence. These are observable phenomena. Well, then nature does what nature does, and a codling moth flies in and starts laying eggs on your apples. That's just reality. We observe reality. Well, what an orchardist is doing when they immediately see the codling moth damage and immediately start spraying to fight against the codling moth is there's this concept, this idea of what this orchard should be. It should be perfect, picture perfect, everything's fine and nothing ever bothers it. There's never any fungus, never any wind damage, never any insects, nothing. Well, as soon as something does come in, that's a problem, and you fight against it with inputs and expenses. That's a radically different approach than another person who does a restoration agriculture approach, plants a whole bunch of apple trees, puts them out in the rows, and maybe, and since he knows that apples like a little bit of weed control, maybe they mow between the rows, or maybe they graze animals between the rows. Well, then when pests or diseases come in, they observe which ones get the pests, which ones don't. The other one is wanting reality to be our idea, this orchard, picture perfect orchard, and we do everything we can to defend this idea of what our orchard should be. The apple orchard, as conceptualized by people, is a very expensive way to produce apples, and we'll go into that later. I've got a big long session tonight, so we want to make sure I fly through this pretty quick. Here's my book, Restoration Agriculture. Buy it. It's now being translated into Spanish. The video is going to be translated into Spanish soon, and we also have a person now that's going to be doing all of the YouTube videos that you see publicly online. Those are also going to be either overdubbed with Spanish or have Spanish subtitles underneath. Now, forest ecology is the scientific study of the patterns, processes, the flora, the fauna of forested ecosystems. Now, forest ecosystem is a discrete land unit that we can kind of like figure out and we can understand and study all the plants, animals, microorganisms, all of the non-living stuff, the parent material of the rock, how wet an area is. All these facts influence our study and influence our forested site. So we have our forest ecology is the study of this particular place as it changes through time. Now, succession is ecosystem change that occurs through a short period of time, decades to centuries. That's what we can see on a piece of property in our lifetime. What I've seen on New Forest Farm in 21 years is a successional process. One of the things about succession is that if we understand succession, we can know what the future is going to be. And people often ask me, it's like, wow, did you know that this was going to be like this, 20 some odd years ago? It's like, well, yeah, we planned it this way. Now, of course, we did the design, the water management design, we put the species in place that imitated the natural plant communities of our area, and then we've managed it as a farm ever since. So we knew what it was kind of going to behave like because we knew it was going to behave like an oak savanna. What we didn't know were the details, and it's those details that we have to accept the feedback from and learn how our management, our disturbance, affects our ecosystem as time goes on. But by understanding succession, we can know the future. And what helps to drive our successional pathway is disturbance. It's any kind of event in time that changes the ecosystem, its structure, which is its shape, its physiognomy, the species composition, or how it functions. This picture right here, I've mentioned before that siltation, covering of one area with eroded material from another area, it's a natural disturbance. This is actually a section of my farm that from all of the floods that occurred last night, all the rain that occurred last night, we had a raging river coming down the valley from the neighboring 100 acres, and it deposited a huge load of silt that it picked up from their cornfields and deposited it across our lower, flatter spots. And we see erosion. So erosion, siltation, both of these have changed the structure of it. It's changed the actual shape of the land. We've eroded material here. We've deposited material here. This is an ecosystem disturbance. Disturbance can be at all different scales, from continental glacier-wide, glacier on a continental scale, mountains blowing up like Mount St. Helens, or it can be a single individual tree that blows over, maybe not even fast, because I've seen places in river bottoms where everything is so super saturated that the wind blows and one tree just kind of slowly falls over and may even take a few days or weeks to finally finish falling over as it like slowly oozes out of the slot. Those are all ecosystem disturbances. So when some kind of disturbance occurs, flood, fire, disease, pest outbreak, whatever, it's important for us as restoration agriculture farmers and ranchers, it's important for us to understand how those systems recover from disturbance and what organisms are going to replace the ones that are destroyed, how they're going to replace them, what the time period is like. And if we look at this system right here, understanding that this place right here is not going to look like this 20 years from now. This place is not going to look like that 20 years from now. This place had had this massive outbreak of bark beetle. Well, we don't know what actually caused the outbreak of the bark beetle. It may have been some other previous environmental insult that weakened or damaged the trees. Sometimes it can be too much water. There's a lot of pines and spruces, for example, that want to have well drained soil. If it's too wet, they'll get all kinds of root fungus. That weakens them. Then a bark beetle comes in. Well, this right here it has undergone a disturbance event, massive bark beetle outbreak. What's the successional pathway that this is going to take? If we understand succession and we understand how disturbance works, we know what the future of this place is. We know what this will look like 5 years from now, 10 years from now, 15 years from now, 20 years from now. So disturbance affects the physical site by creating new landforms. All of this soil, this is close to 2 feet deep. This is again on my property, right? It's about 2 feet deep of topsoil that came from the neighbor's farm and got stuck behind a brush gabion that I built here in the middle of the valley. So we've got a new landform, new flat ground. It's probably pretty fertile soil if you don't mind all the hormones and antibiotics and cattle birth control pills and stuff. One of the things that I wanted to show with the both of these silt deposition photos, this one included, is the fact that soil mixing to a certain degree is natural. It's normal. It's part of the natural way that soil, rich fertile soil, is created. That here, new raw mineral soil, crushed rocks, are deposited on top of these finer silts are in here, right on top of previously existing vegetation. That previously existing vegetation now starts to decompose. You've got new rock up here that's oxidizing. We now can go ahead and flood it again and bury it again. Now we have all these mixed layers of minerals and organic matter and decaying organic matter. So what we do is we're accelerating the process of creation of soil. So not all soil disturbance is detrimental to the creation of rich soil. Disturbance will change the light and the temperature regime of the site. Any of these trees that were ripped down no longer cast shade, so there's more light in there available for other plants. We now have new substrates available here for plants to get sprouted in. So by understanding how the disturbance works, what types of new conditions it provides us with, we can now select the proper response to this disturbance. How are we going to interact with this? Because now we know that nature has created for us new site conditions. How can we capitalize on this to create current short-term and long-term yields? All of these disturbances, from light, temperatures, sand dunes, deposits, sediments, all that, have long-term effects on the life of the area and even the hydrology of a region. Now, exclusion of disturbance is its own kind of disturbance. We've talked about this before, is that the exclusion of fire in fire-dependent systems is its own kind of disturbance. Something that was normal here way back in the early part of the 19th, 20th century, 19th, 20th century. There's most of the redwoods were these open grassy parklands, same with Ponderosa. Much of the Intermountain, Great Basin, the Pacific Coast were open, gladed, savanna-type systems with these gigantic, large, wide-spaced, open-grown trees with grasses underneath, all kinds of wild animals there. Well, when we excluded the fire, which Europeans thought was totally damaging to the trees, and it does kind of damage to a certain extent, it was actually what was perpetuating the system and keeping the system the way it was. Whereas now with the trees with no fire, they get tall enough. If a fire happens to come through here, the fire can get so tall that it'll torch the tops of these trees, and these ones will die. It'll wipe the whole system out. Instead of just maintaining this system, it would destroy this whole system and it would start somewhere else in succession and go forward. So by understanding how these disturbances work and interact with the different species, we can predict to a certain extent what our system will look like, how productive it'll be in the future. Now, most communities don't start from scratch, for example. There are biological legacies. Wherever there's some sort of disturbance, there's some living things that are left behind. In this case, redwoods in the middle. These are like 20 or so redwoods in the middle of farm country in Northern California. These guys are now starting to reseed. You see a couple of them in here. When the conditions are right, they can continue to spread. So we've got a legacy to help move this forward. No matter where you are, most places, I can't say all places anymore because I know that there's some places that are really, really trashed. Almost all places have some sort of biological legacy, something living from the previous ecosystem that will now help to establish your new successional system and drive it in a particular direction. In some cases, you'll have these biological legacies not necessarily on your property, but outside of your property, dropping seed on you all the time. And so you're going to have to understand what they do by colonizing their site and somehow work with them to bring your site to the productivity that you're looking for. Some of the physical legacies left behind are like bare or rearranged mineral soil. So remember this: we have legacies left behind. We have bare or rearranged mineral soil for new seed beds, new microtopography. We have pits, we have mounds, there's debris flow, sedimentation, erosion, you'll see it. So these are the physical legacies left behind. These will also affect what we do in the future. New erosion gullies on the farm will tell you, okay, I got to deal with this somehow. First, let's try to prevent them before they happen. Well, if they happen, how did they happen? Why did they happen? Can we do a preventative measure? Now, how do we repair the damages that's there and actually help use these new exposed sites to propagate a new successional pathway? You know, the pit and mound, I once again show that naturally, totally normally, we're mixing the mineral soil with the organic matter. The organic matter is decomposing. We're creating a low spot for a little puddling of extra water here so these young little seedlings don't dry out. And there's all this nice organic matter decomposing. The pit and the mound architecture is a common disturbance feature. And also in talking about animals, I talk mostly about grazing and trampling and browsing when the animals are eating the trees. I didn't talk much about what ground burrowing animals do. This is an example right here. This is this is actually a badger digging after a chipmunk. Badgers dig incredibly fast, and basically, if a badger goes after you, you're doomed, and it'll just burrow in the ground and disappear in like 3 or 4 seconds. So chipmunks, in the first place, they made these tunnels in the ground, and they're bringing mineral soil back up and throwing it out at their doorstep. Badgers are going in, they're really churning it up. So here's some disturbance. We're mixing mineral soil with organic matter. That's helping to accelerate the creation of a rich, fertile topsoil. Well, and we're creating drainage. Now there's air that can go way deep into the soil profile, however deep the chipmunk or the badger went. Now there's oxygen down in there. We have an oxygenation or aerobic process going on. There's more life in an oxygenated environment, at least as far as we know. So here's mixing, aeration. Well, then, of course, when it rains, which I've got some pictures that will show, these now become the bathtub drains, and water goes down these holes deep into the soil strata, all through the network of tunnels, and it slowly soaks in. This is, I just had to take this picture because this is absolutely brilliant. This is a depression, and here's a box elder tree. Pay attention to this box elder tree, because I'm going to take this one picture here, then we're going to go around the other side and take a picture there, and then stand here and take a picture here. That right there is a badger den. About 5 years ago, we had a family, or actually a pregnant mom. A badger moves in. She raised 1 young, 1 year, one, then 2, and then 1. So she's 1, 2, 3, 4, 5 kids she's had in the last 4 years. So what she's done is she's excavated this den. However, it's kind of located in a valley spot. So what she did is she also excavated all these tunnels here. And anytime any water collects on the down to the bottom part of this picture, it falls into her pre-dug tunnels, and it goes over here and down a bathtub drain that she made. So this thing can get like 2 feet of raging water roaring down in it, and that stays dry. And so then down the back side here, you can see all the debris that came down into her pre-excavated tunnels, and she's bringing it around this side of the tree. She dug these swales and berms, not me. This badger did it. And then you can see the debris is where that final drain tunnel is. This is her cave, or her den, and this is the drain spot. So this drains over to that spot, and then this drains over to that spot. This comes this way, goes around front of the tree, and down that hole there. Her den is under here, perfectly dry. And I've seen this thing with raging 2 feet of water roaring down in these holes, and her spot is totally dry. So tunneling, this moving of debris, mixing of mineral soil with the organic matter is totally normal, it's totally natural. It's doing something. Let's understand what it's doing. Part of what it's doing that I really like with the water management strategy on my farm, you see how this grass is all laying this way, and then we've kind of got this piece of goldenrod that's kind of swirling, and you can just see a little bit of the pattern here, how this water I wasn't there when the water was there, was swirling down this rodent hole. It's either a 13-line ground squirrel or some sort of vole or something that did this. This is especially exciting for me in the wintertime when we have frozen ground. We have a rain on frozen ground late winter that happens quite commonly around here. There'll be water flowing in the system. Photo album here of the picture of the water going down the hole in the wintertime, and I couldn't find it. But most rodents that are tunneling in the ground, if they're going to be hibernating in the wintertime, they're not stupid. They dig their tunnels down below the frost line, so when the water flows across frozen ground, it's not soaking in, and it goes down their tunnels, hits the thawed soil, and it soaks in down there. Here's another example. You can see how the water can even wash the grass right down into that little hole there. There's oodles of bathtub drains. Now, if I was putting rodent poison out to kill all these rodents in my quote-unquote orchard area, I wouldn't have the benefits of water infiltration, so I'd probably have to use drip irrigation to get the irrigation that I'm not getting because I'm letting all the water wash away. Goes in, must come out. This right up the top of the screen here is a rodent hole. Just look at all the sediment and debris that has come out. So here's more ecological disturbance. The material that was all green and wonderful here got buried with more silt and chunks of plastic and whatever else it is that was in that hole and got washed out. And just to show you a couple of things around, you can go online and look at all kinds of ridiculous pictures of animal tunnels. But in their tunnels, so these tunnels now, water's flying down in it. Well, some of these that are up like this, and up like this, up like this, the water goes in, and now they're in an airlock chamber, and they're perfectly safe from all this flood water that now goes down into their other tunnels. And no doubt, as soon as the water starts flowing down the walls, they're like, honey, let's go up to the nursery and spend the night up there. So they go up there, and I've never seen rodents getting washed out of their tunnels. So somehow they've got these little safety rooms in there that are airlocked up above the water. Now, what's really significant, how it relates directly to restoration agriculture, is human disturbance is a disturbance. It still is. Like in the case of mining here, it may be a lot more devastating than some kind of natural disturbance. Arguably, this is no more disturbing than volcanic eruption like Mount St. Helens. And what's even fascinating about this is even in serious mining operations, strip mine, mountaintop removal operations, there are still legacies left behind. Wind-blown seed still comes in and colonizes it. Fungi are somehow still able to colonize, and mycelium goes all through this mess, even if it's toxic, believe it or not. There's life in there. There is some sort of legacy left behind here, and it is still going through succession into the future. All these different things, logging, mining, fire suppression, construction, settlement, clearing for agriculture, all of these are ecological disturbances. And if we remember that disturbance is an observable event in time that changes the structure, species composition, and the function of an ecosystem. Agriculture, how we get our food, is an ecological disturbance. This is I argue, a fairly massively disturbed site. This is corn in Iowa. As far as the eye can see, whatever this was before, whether it was prairie or savanna, not likely that this site was forced. That ecosystem was destroyed. The soil was exposed, probably originally with mules and a plow. Nowadays, the ecosystem that wants to survive and grow there, beginning with weeds, begin the successional pathway back to some sort of stable, diverse ecological state. It's always arrested with herbicide or plowing. This is an ecological disturbance. Most of the species diversity is gone. It's kind of like all settled down to one, and that's Zia maize. Now, human beings have been getting food a whole bunch of different ways, and all of it involves some sort of ecological disturbance. And one of the most significant ones that we know worldwide, one of the most significant landscape shaper changers disturbances is fire. Well, we happen to be the critter that really has embraced fire. We can use, once upon a time probably used it to scare prey animals. We've used it for cooking food. Proteins that were previously undigestible now become digestible. Food that has gone too far and it's a little bit dangerously rotten now becomes less rotten, and it's not as poisonous to us when we cook it. We can use it for scaring away the boogeymen at night, like these lions. We can use it for lighting our cave. We can use it for burning out in the bush to remove extra brush so dangerous things don't hide in the bushes and come after us. and it will foster grass growth so we can see our prey, which would be large grazing animals. And it's always also been used as ceremony, as fun, a way to bring people together. So fire, not only is it the most significant landscape disturbance, it's also one of the most significant things in our own life as human beings. We may not do these activities this way very much anymore. I haven't been hunting mammoth in a long time, but we still use fire in various shapes or form. All of our ignition combustion engines are based on fire. All of our electrical motors are a fire-type process. Fire is what drives our culture. So once upon a time, we were hunter-gatherers. Well, then somewhere along the line, slash and burn agriculture got started. Well, it didn't got started and then just finished. It's been going on forever, as long as people have been doing slash and burn agriculture. This was taken this last February in Nisindi, Uganda. 10 years prior to when this picture was taken, this was a tall, they call it a high forest, a high monsoon tropical forest. There probably were chimpanzees, all kinds of wildlife out here in this high forest. Amazing diversity of plants and animals. Well, human beings come along, folks who practice slash and burn agriculture, they come along, they cut down all the trees. One of the biggest activities for this particular wave of humanity that's going into the forested areas, cut the trees down. Modern times in the U.S., it's all the loggers going in, cutting the trees down, and then the next wave of development of agriculture follows after that. Well, the first wave here, in this part of Africa, the slash and burn people, they come in to make charcoal. They sell the charcoal for money. Well, now they have money to buy food and clothes and cell phones and all that kind of stuff and get to town, buy some alcohol. All of a sudden, once all their trees are gone, they don't have any more charcoal, more trees to burn into charcoal, so they don't have any more income. They've always been growing a few little vegetables and stuff in the ground, but never enough really to feed them. They've been abusively grazing their animals. By abusively, I mean they're using it to continue to tear the forest down. So they begin to live poorer lives because they've degraded their resource base and they don't have any more cash income. So they move to the next space and they do it again. They know, as a personal example, for real, and it's proven in their life, our life is better when we're destroying a forest and making charcoal to get money. They really experience that. They don't necessarily see the insidious agricultural consequences of being invaded now by annual agriculture. Here comes the big flat green, owned mostly by people who don't actually live there. These are fields that are either owned or leased by the U&I Sugar Company right here. And so by understanding succession, we know the future. We know that if you destroy the forest and expose the ground to plant annual crops, you depauperate the soil. The soil loses its organic matter. The soil food web shuts down. Nutrients don't cycle as much. Water doesn't infiltrate. You have bigger floods. Now plants don't grow as much. You don't hold as much water. Droughts are worsened. And so here we got right here. This is not corn. This is not Iowa. This is Uganda. This is sugar. As far as the eye can see, this is what was once upon a time, 10 years ago, this was high tropical monsoon forest. And this is what the people get to live on. These are their farms, like the size of most of our American homes is the size of a piece of land that families have to live on, and they have to raise all of their food or else starve. It's really the way it is. So you wonder why people get violent when all of a sudden they don't have any food or clean drinking water or whatever. This is from an actual site that I worked on, where they had started to realize that if they made pits in the ground, at least a little bit of water would concentrate in those pits and they could get some crops established. They were growing mostly in this area maize, a certain kind of bean, some lentils, and cassava is their staple food crops. Well, if you grow just maize on this ground and you get no rain when you need to have rain, you don't have any maize, your family starves, so you have to start stealing or go to town or whatever it is. By destroying the original habitat and plowing the ground every single year with no regard to ecological realities, that is a continued catastrophic annual disturbance. Every year this gets plowed again, either with an ox or by hand tools. Same with in Iowa. Every single year they spray that ecosystem dead with herbicide and they start over again. That is a catastrophic reset button going all the way back to the very beginnings of succession. And this has always led to complete ecosystem destruction and the collapse of the societies that were dependent on those practices. The charcoal burners, subsistence gardeners are destroying the very resource base that they need to stay alive. And it's actually by destroying the resource base, that's what keeps them alive. Well, let's look at ourselves, look at our industrial culture. We're destroying forests worldwide extremely fast. We're depleting aquifers. We're poisoning aquifers. We're poisoning groundwater. We're fracking this. I mean, we are messing the system up as fast as we can. And of course, because economic growth is what it's all about, right? Well, we can have economic growth. We can change the way we do things. Here's an example. This is an island off the coast of Greece. This particular island is Kea, I believe it is. There were once upon a time 150,000 people who lived on it. It's a rather small island. There were 4 separate nation states on the various different mountain forms. The whole thing was once upon a time. It was oaks, olives, chestnuts, pomegranate. If you want a fascinating read, go to the beginning of, I believe it's the Odyssey by Homer. He describes sailing by the coast. It could have been this coast right here. And he describes the most incredibly rich, luxuriant, abundant place, all these perennial trees and bushes and vines, all kinds of fruits and grapes and nuts. Well, then what happened, of course, is they began to, at least they made terraces. You can see all the terraces remaining. They would clear cut everything to plant wheat. This became one of the granaries of the Greek Empire back during its big golden era when Athens rose to prominence. Then all of a sudden there weren't enough people to work all of the land, and so they had to bring in slaves. So slaves would work the land, growing all the grain that fed the soldiers that marched on all the different superhero movies and whatnot, and built all of these ridiculous temples. So now what's happened, look at Greece, it's probably one of the, it's one of the worst off economies in all the European Union. One of the best things they got going for them is ruins. The previous glorious civilization was there, fell apart because they destroyed their resource base. There are other futures possible though, and we can know them. We can understand them. We don't have to, wish and hope that things are better. We know how ecosystems work. We know that if we collect a little water, soak it into the ground, we're going to have more moisture over a longer period of time available for plants, whether we're growing annual plants or perennial plants. We then know that if we plant trees, various different propagation techniques from cuttings, or these are shoots that grow off the side of a banana, or from seed, we can actually grow these plants. Through time, they're going to start to cast a shade. This ground will be cooler because there'll be a little bit of shade, which when it's cooler and there's some shade, it won't lose its water so much. It will start to grow through time. We'll use a little bit of mulch to hold in some of that moisture. And if we're planting all food trees, which these are right here, and if we're doing it in an alley cropping system, we can still grow, our maize and our sweet potato or our cassava in the alley while we're growing our polyculture of tree species with water management involved. We know that we can choose a future. You can choose a future that looks like this. We can choose this future by continuing down the path of destroying our ecosystems to grow our food, or we can replant the ecosystems to grow our food. So these guys right here are replanting their ecosystems. These guys now all are living in the United States. I think he's a sophomore in high school in Tulsa, and he's a soccer superstar. Big, tall, lean, fast-running Tanzanian kid. So we can choose the future that we want to experience by planting it. And this is me in that exact same spot a mere 4 years later. Has it changed? Yes, it's changed. Did I know it was going to change? Of course I did. Did I realize that it was going to change this fast and be that rich and luxuriant? Wow, I didn't know the details, that's for sure. It was a delightful surprise. This is Farmer John. He's the guy who now runs a food cooperative or distribution cooperative. This site right here is on a school. You can see these are the dormitories for the kids who stay there in residence. This was a system designed to feed the kids that go to this school. Well, John lives in one of the small villages next door. He got a similar system started at his school. He owns a truck, which not very many people there owned a truck. And so all of the neighboring farmers, when the bananas are ripe, everybody's eating bananas as fast as they can, but there's extra. There really are extra. We've now created an abundance of certain foods. When the mangoes are ripe, the bananas are ripe, whatever it is in season, we try to schedule it so there's something ripe every season. They've got a little bit of surplus apiece. If I've got 4 extra mangoes, it's not going to do me any good. I can sit out by the side of the road and nobody's going to buy it. Or me and my neighbors all just pool together. We put them in boxes. We put them on John's truck. He takes it to town. He sells it. He comes back, distributes the money, or actually he picks up stuff on the way back from town. This is the same exact doggone site. It's 5 years later. The tall trees, these are banana trees. There's quite a few different vining beans. They also grow a lot of squash in the shade. There's vanilla vines. They've got passion fruit. They've got guava, tea tree, black pepper tree. Just a wide diversity of plants. Macadamias. Have you ever seen macadamia nuts? This system behaves differently than the bare dirt sand where they started from. Jackfruit, it's the world's largest fruit. You'll get like fruit this big, 35, 40 pounds. It'll feed a family for half a week. It's a weird kind of thing. It's like these little seed pods that all stack together. It's all soft and juicy and sweet. You pull it off and eat its seeds at all. So it's actually incredibly delicious fruit, fairly high in protein. There's breadfruits, jackfruits. There's coffee, this is cocoa, all growing in their system where they had nothing before, nothing but sand, and then, of course, bananas. We can know the succession of a place. This landscape-scale cereal grain ecosystem, it has a particular disturbance regime. Every single spring or every single fall, if it's a winter wheat, the ground is prepared with an herbicide, so any living thing is killed. Then we plant the wheat, and then X months later we harvest the wheat and repeat the process over and over and over and over again. Biodiversity goes down to 1. The opportunities for people to actually live here, fall away to almost nothing. There's no way for humans to make a livelihood, hardly any wildlife. This is a depauperate system, and the food, if you call it food coming off of here, it's an empty carbohydrate filler that barely keeps you alive. The disturbance regime of this system and its ecological effects are radically different than a wheat and bean rotation alley crop with walnut. Here's the same thing. We're still growing large-scale annual grains. However, we have another element involved here. We're doing a crop rotation, wheat, beans, wheat 1 year, beans 1 year, wheat 1 year, beans 1 year. Then we have a woody component where we have walnuts growing in there. While the walnuts are maturing, pulling off of the wheat, and within 10, 15, and long term we have timber. We now have a almost infinitely incalculable, more diverse system than this. Different disturbance regime. And this is different than the restoration agriculture process. What we have in this photograph are 3 different layers of clover, a white clover which grows close to the ground, a red clover in the middle, and a yellow sweet clover which will eventually overtop the rye. This is not wheat, but rye. All right now, when it's ready, it can be harvested however we choose to harvest it. And then the clover grows up tall, and when it casts seed, we either roll it, mash it, trample graze it. By accumulating extra organic matter, that's what those practices are doing. They're accumulating extra organic matter. We have extra carbon in the soil, which is the energy. It's the fuel that runs the whole soil food web, which makes things grow better in the future. So we start a regenerative process in the direction of succession. We also have planted here a whole host of woody species based on what the woody species were and have been historically in this area, the ones that will grow most likely to grow and succeed with sheer total utter neglect. We arrange them according to the pattern of water management distribution, and we actually plant them and maintain them and sometimes harvest with machines. Now, this apple orchard produces a lot of apples. It has a different disturbance regime and different ecological effects. What I'm trying to do here with these different systems is to show you that this is different than this is different than this. What this third picture has right here is way more biology going on. This system is full of life. This is full of wheat. The wheat growing in the ground is only alive because it's kept alive with chemical fertilizers. This is a very input-intensive system. It depends on cash to be able to buy the inputs that you need, the availability of the inputs, which are mostly mined substances transported over long distances. This is an expensive, very fragile system. You have a hiccup in the fuel supply that runs these tractors and combines, that whole place shuts down. That's a different system, radically different system than this one. You could all of a sudden have the same fuel system shut down and you don't have as many grains, but you have another thing to rely on. We've got the walnuts as a backup. Or maybe this is small enough we can actually do our small grains with hand tools. This system right here, there have been years that I've done 0 annual crops at all because I couldn't afford to, and we just kicked back and harvested the yields off the perennial crops. It's a radically different system, different amount of inputs, 0 pest control inputs in this system for the past 21 years. No fertility inputs other than a few mineral amendments here and there banded right in the row with the crop that we're growing in question. Same thing with these trees. These are perennial crops. This is good. If we're going to start eating more permaculturally, we've got to eat more perennial foods. I would rather see you eat perennials that were grown this way than wheat and corn because it's just a little bit more alive. We have grass growing, which means we probably have some underground critters and fungus. There is organic matter in the soil here. And we've got trees. We've got fruit, and so we probably also have pests and diseases up here. There's a lot more life here, but there's still an input-based, very fragile system that is dependent on toxic chemicals to keep it going. Has a different disturbance regime and ecological effects than this one. This is at my farm. What's really fascinating about this, looks like I'm getting plenty of yields here, not just apples. The yields start in the spring with cyanwood that's cut and sold for other people to graft from specialty, rare, and odd varieties, cut flowers, and honey, comfrey root and tops, iris roots. Of course, then there's cattle and hogs and fruit, but in this picture, we didn't have the cattle in here yet. Plenty of grass, bees, honey. Now look at the difference here, where now that the cattle are introduced into the system, they've pruned the branches right up. These are snub-nosed, hornless cattle. Actually, these are pigs, obviously. They're cleaning up the windfall apples after we've already picked the low-hanging fruit that's looking good. What's the difference between this one and the last one? This one has a lot of low branches to the ground, and this is a very humid. You see it's shady here, a lot more humid. A lot more fungal diseases can get established in here, and then a spore, all it has to do is splash up and catch this leaf and splash up and splash up and splash up. So ladder fuels that would allow fire to climb a tree are similar in that they would also allow fungus to climb a tree during wet circumstances. So all of our trees now have 5 feet of zero branches down low. Very few fungal diseases in these trees, and we get plenty of yield. Thank you very much. This type of hazelnut orchard is a different disturbance regime than someone like this. This is in Minnesota. This is hybrid hazels, bush hazels being grown in a field. No herbicide being used, lots of herbicide being used here. These are European hazels that want to grow into a multi-stem shrub, but are pruned or trained, or a hormone is applied to prevent it, a sprout inhibiting hormone sprayed on that to prevent it from turning into a shrub. So there's extra pruning involved. There is grass and there's hazelnuts. It's a good 2 different things for diversity. This, on the other hand, had no herbicide, no pest control, no disease control, and these are American hybrid hazels, which are more of a shrub form. Let them be a shrub. So we have to harvest them differently. This is different than this, which is different than this. Chihuahua, excuse me, hello? So this is all hand harvested. This just took place this last weekend at my farm. This is a crew harvesting seed from some of my top producing hazelnut bushes. And everybody can participate. This is just a different system. It's different effect. And what we need to know by seeing all these different systems, which one do we want to have? Which type of system do we want to have? When we do something in our system, when we hand harvest hazelnuts this way, or if we machine harvest this way, or if we keep our orchard with an herbicide band underneath. It's herbicide application, there's root sprout inhibitors, there's pruning, There's 3 different inputs. There's mowing the grass, 4 different inputs. No doubt there's spray for pest control, disease control, 7 different inputs involved in the system to get a similar thing here, the crop of hazelnuts. A lot fewer inputs here. We're still mechanically harvesting. Even fewer inputs here. What system fits your lifestyle, your family needs, your personal moral values? What system can you do, actually? Can you afford to do? Can you afford to do this where you just plant these plants, you graze the grass? Look at all the trampling footprints from the cattle. You graze the grass with animals in order to get the grass to be short. The fertilizer comes from the animals, obviously, of course. So instead of having grass mowing taken care of by a piece of equipment that I own that falls apart that I have to buy fuel for and fix that doesn't work half the time, that's an input, that's an expensive input, I can use cattle, which are grazing that grass off short, and they're adding a fertilizer that I don't have to add with another machine that breaks down and buy this fertilizer from somewhere else. The animals are taking care of that job for me. And then when we're going in and harvesting, actually there's a lot of my hazelnuts right now, we're letting the cattle harvest them right off the shrub. It's really pretty cool. Here they are, right there, there's the moose. So really, we need to harvest it for human being consumption. We don't have to eat the hazelnuts. We can eat the animals instead. So I guess I'm a lazy vegan. Instead of eating the hazelnuts myself as my protein source, I let the cows eat the hazelnuts, and then I just kill one cow and eat them all winter long, or something like that. This method of raising beef has one particular disturbance regime. It has a real, measurable, quantifiable ecological effect. The ground, it's in a near desert almost, so there's hardly any rain, hardly any vegetation. It's all trampled to death or eaten like years ago. The animals stand around, they poop wherever they go. Since it's so dry, the poop mostly just dries up, and it's layer after layer after layer of hard compacted animal manure. Well, then when it rains, all that animal manure goes flowing down into the local closest streams. These animals are in close confinement. They're fed concentrated feeds from outside. They need a lot of antibiotics because when it does rain, there's all kinds of parasites and pests and diseases that take off in here. So this is a very input-based system in order to get beef. This is another way to get beef, has a different disturbance regime. This is Greg Judy's farms, where he has field openings in a matrix of forest. He has some that are savanna also. It's fairly densely stocked, mob-stocked rotational grazing system. This is a 40-acre field at 300. There's 300 animals out here on a 40-acre field. They were just let in like 5 minutes before this picture were taken, and they'll be moved again in the morning. That's a radically different system where you have the trees on the outside and the animals eating the grass. It's different than this system. Now think about the differences that's happening right here. We've got cattle, yes. We have cattle with very little expense. We don't have to add antibiotics. We don't have to deliver their feed. We don't have to have thousands of acres worth of corn and beans being grown and combines being manufactured and trucks transporting it to the farm, putting it in storage silos and conveyor belts moving it to the animals. We don't have to hire a person full-time just to go out with a skid steer loader and haul away dead animals. We can have a system like this, and we have our animals. But what else are we harvesting out of this system? He harvests nothing else other than his animals. Well, here, we've got our animals. We're harvesting the animals. And we're harvesting nuts off the walnut trees. Eventually, we'll be harvesting timber. Right now, we're harvesting firewood. There already were, if you notice, it's lighter over on that side over there. I already harvested hybrid poplar out of there. The bottom of the hybrid poplar became a building that is now our cider mill building. The middle ones became, we inoculated those with oyster mushrooms for consumption and sale. And then the smaller ones, we either chipped in place or we used for firewood. And then you notice there's mulberries in here as well. Well, these mulberries, yeah, we pick some, we make some jams, jellies, and alcoholic beverages, but the main reason for having the mulberries around are for the pigs. So out of the same system, ecological system, we've got cattle, pigs, mushrooms, walnuts, trees, grass, zero inputs, zero inputs. One of the things that I've lived for umpteen years, I can show you guys how to run and manage a farm or a ranch with zero inputs, as close to zero inputs as we possibly can get. We can't leave. We have to harvest. We've got to be part of it. Sometimes we'll do some minimal fertility amendments with ground rocks and stuff like that. But this is as close as you can get to inputs. Zero is a very affordable number. I can't afford the investment that it takes to buy this much land, to buy that much infrastructure, the fences, the watering, the labor, the chemicals, the feed, the storage for the feed. That's an expensive proposition. It is very fragile. One little well-placed fuel crisis or worker strike, and this whole system right here shuts down. Whereas this one, a lot more sustainable. This one happens to be dependent on a lot of rented ground that Greg Judy has a lot of landowners, absentee landowners around him that just want somebody to manage the land and that they don't have to pay. So Greg Judy manages the land for them, and he doesn't pay rent. They don't have to pay to have the land managed. It's a good win-win situation for both of them. But if all of a sudden, if the economy turns around and real estate starts getting more expensive and people want to start renting the land, his no-rent formula is going to disappear, so that's a little fragility of this system. Whereas this system right here, the biggest fragility that I can see in our system is the fact that we aren't pushing yield. We aren't pushing raising as many beef as we possibly can, raising as many pigs as we can, as many trees as we can. We're not maximizing anything. This is a real easygoing, laid-back, get-by kind of system. If we wanted to push it, it would require more work and more attention, but I'm lazy. I don't want to do that. So now let's go to growing pine, for example. This is a zero input method of growing pine. This is in a designated wilderness up in Boundary Waters Canoe Area Wilderness in Minnesota. Because it's designated wilderness, human beings do nothing to this other than visit. This was the location of a fire, I believe, 3 years prior to when I visited this site. Look at the structure, the physiognomy of this place. Fairly large trees, straight and tall, not a lot of ladder fuels. The trees have rough bark. This is a fire-managed ecosystem. So it's a zero method input of growing pine, but what are the yields for human beings? Because it's in a wilderness area, we won't even eventually harvest the timber out of this. This will all just be part of the natural process, but it's a great place to go and study how does this system work. How can I plug into this system and actually obtain yields from it? So zero input method of growing high quality, super straight and tall, knot free, high volume of pine. Well, what about this? Don't they look kind of similar? Look at that, and look at this. This is also in a fire managed area. Look, there is a human being here. But this is a system that I've been working on for a number of years with the landowner, and he's been on a 10-year conversion process of converting from prior use to a silvopasture system with one of the long-term goals of growing timber. And this is all pine, southern pine timber. But he's doing most of the ground cover management, not with fire, but with animals. He's got this look, but with animals. If the animals were to come in here, say cattle, for example, they'd chew all this down. There'd be more opportunity for grasses to grow. You could actually overgraze all of the brush in here and have grasses re-sprout if there were grasses in the forest floor, or you could top seed with grass seeds to get your grasses established that you want. He never planted any seed here. And actually, this site, there's quite a few videos. Those of you who are members of our Economics Action Team do know, of course, that pretty soon we're going to be starting to charge for this service. One of the things is when you are a member, you have access to additional trainings that will be further on our members page. There's several different videos of this site where I narrate and talk about all the different strategies of what particularly did we do at what time in order to get this to look like that. Here's another way of raising pine. This was an area that was previously clear-cut, or it was a field that somebody planted rows of pine. They probably did herbicide for a few years, or they mowed for a few years, and it closed the canopy, nice and straight and tall. But there's it's a monocrop. There's hardly anything alive in here except for a few, adventitious trees that somehow managed to get established in there. very, very much sterile, devoid of life. Here's other systems, other ways of doing pine, larger land holdings. Oftentimes, if they're clear-cut or replanted or not even replanted, you use a selective herbicide to kill the plants that you don't want and let your plants grow. But how much does a helicopter cost, people? You know, most landowners are not able to afford a helicopter. What this guy's doing right here, I'm not exactly sure. I do know that in some places there's a lot of folks that you wait for a good seed yield on your woody species, and then you go ahead and scarify the soil, because if we want to disturb the site, remember, some of the things that disturbance does is make new soil exposed for new planting mediums and so on, and it reduces competing vegetation. We can reduce competing vegetation with a mower, we can do it with a disc harrow, we can do it with helicopters, with spray rigs, or we can do it with animals. Because in this picture right here, I'm standing right here, this is there's a landowner, and this is my engineer contractor guy, Eric Berg, he's on the red team. Turn around in this picture and I look right here, this is how he manages this system. He uses the cows and a portable electric fence to keep down. He uses himself with a chainsaw and his tractor to remove trees that are crooked or widespread to allow a little bit more sun into the forest floor. He's replanting. He's thinking ahead because he knows how it works. He knows that eventually these pines, if he doesn't harvest them, they're going to get old, they're going to snap, they're going to start rotting. So if he wants to have some value out of them, he can actually remove them sooner instead of later, let the smaller ones grow. So what he can do is come into this space here and plant a shade-tolerant species that likes a moister site, such as pecan. He's growing lots of pecans. Putting in these sites here to start growing, then a few years later, he can begin dropping trees one by one. He has his own portable sawmill, and he sells lumber as a part-time business. This is a great way to interact with this resource base in a manner that actually helps it to grow. We can increase soil organic matter. We can increase species diversity. This is not a monocrop way of raising pine trees or cattle, for that matter. Some of the young stock, and I think it's a lot more beautiful than a lot of different ways other ways to grow pine or cattle. I'm going to do a hurry up finish here. So fire, of course, has been the dominant disturbance factor in landscape history worldwide. How do we understand how fire impacts the system? How do we imitate it? We can imitate it with helicopters and spray. Part of what it does is it does not continuous, it's discontinuous. More vegetation is removed over on one spot than another part. It's heterogeneous. It's a mixed hodgepodge of burn what's left behind. That sets in motion the regeneration of the next forest. And if we know ahead of time that we're going to disturb a site either with fire or mowing or with cattle, and we go plant the species that we want, we know what the successional pathway is going to be. That previous landowner with the cattle under the pines, he knows that he's going to have a pecan growth by the time he retires. Disturbance affects different plants differently. They reproduce differently. They have different survival techniques for fire, from root sprouting to basal sprouting. Ground layering, thick bark. Ground layering is like if a willow tree falls over in a flood and touches the ground, the place where it touched the ground will start sprouting up again. And then other things like this, fire-resistant species, fire-adapted species have really thick bark. Look at her fingers there. Her fingers are buried up to the knuckle in these deep, deep cracks of this thick, corky bark. And they have light seeds that can blow all the way in. If you remember from a week or so ago talking about Burnt Island, how did that seed get there when this was burned as a rock when my dad was a little kid? The seed blew in the wind. These are all fire adaptations. We understand that when we do a disturbance, we're going to create this in a lot of trees. When I go through and I cut black locust, I know it's going to behave this way. I know if I mow this off, it's going to continue to do that. It's like the hydra. I know if I cut certain species, oak, mostly on my side, or chestnut, they'll respond by putting out multiple stump suckers. And I know that nearby things with light seeds, like willows and aspen and cottonwood, will be floating in the wind and landing on my site, and landing on anything that's disturbed and sprouting and taking over that particular area. If we understand our successional pathway, we understand how disturbance works, we can steer our systems through time using disturbance. We can reduce competition. Think of all the different ways we can reduce competition. We can do it with fire. We can do it with machines. We can do it with chemicals. We can do it with animals. How do we want to disturb our site? What do we want to establish there once we have disturbed the site? Why are we doing anything in a particular place? We want to leave it alone and just observe that site? That's valuable in and of itself. But to understand how these disturbances work and how the system responds is really crucial for our understanding. We prepare seed beds. This is just overland flow after a fire. We're exposing that soil so new seeds can get established. We get rid of organic matter to a certain extent, because if we're going to get trees established, we want to, either use some herbicide or some plow, scratch a line with a subsoiler, use a shovel, use some mulch to kill any living plants there, just to change that ecosystem, that micro ecosystem, to favor our new plants. So what's this site here? We've talked a little bit about the pines, and this is obviously a pine stand. It actually was burned, I think it was like 5-7 years prior. We know that how pine systems operate, because we've done a lot of studying. We look around, we observe other systems, that fire is a major issue here. If you look at the bark of these trees, it's burnt down at the bottom. So this place gets periodically, episodically burned. How can we steer the succession on this site? So one, we know that it's fire prone, so it's going to behave like fire prone site does. So let's interact with it in such a way that it imitates what these species can tolerate. And let's create either new conditions for new species or more optimized conditions for the species that are here, and maybe prevent a little bit of the fire, prevent the negative impacts of fire, because if we only have 20-30 stems left per acre that got left after a fire, we might want more stems per acre. And maybe we want some grass under here for grazing animals. Maybe we want openings for growing annual crops. So maybe we use a hydroaxe. This is an amazing tool. This site that we're about to see was a post clear cut. We went in with the hydroaxe and with a bulldozer. Let's imitate a pit and mound architecture. Any stumps that were in the way are now incorporated into this mound. So we have our swale and our berm. It's all designed to spread the water out from the valleys to the ridges, soak it in. We expose some soil to the light. We have more light available because we're going in with this monster, chewing it all up. We can get some grass seed established here. Now we've changed the forward succession of our system. It's like one chiropractic adjustment, and it's off and running in a totally new direction. The water is now managed. It's spreading to the ridges, like I said before, and observe the quasi-pit and mound. All these different roots are embedded in that guck. Then we use the hydroaxe, go through here and not destroy all of our regeneration. Remove some of the plants that are not necessarily desired on the site. This is a southern, southeastern U.S. pine situation. So once we get the water managed, we get that grinder. Notice how there's still a fair amount of stems that we left behind, and there's some of the young regeneration, but it's wide enough apart so that we'll get grass established underneath it. So we grow grass, and then one of the hottest new herbal medicines on the market is saw palmetto. Saw palmetto is used for prostate issues in gentlemen, and with so many aging baby boomers and Generation X's, it's a massive growth product. So what we've got here, this is practically a wild southern pine savanna. You got all kinds of grasses in there. There's Venus flytraps. There's the saw palmetto, obviously. There's all kinds of wildflowers, and you've got pine. In the north, I would want to be growing pine nuts for my pines, so I could be having Korean pines. I wouldn't be able to grow saw palmetto up in the north. And actually, I think what I'm going to do, because we're already after time, is I'm going to cut it right there. So I hope what you get an idea of here is, in a restoration agriculture system, is what we're going to try to do is imitate the natural ecosystem in the plants that we choose, and then in the techniques, how we disturb that site, and then we establish our new successional crops, and we manage it as naturally as possible so it can be as affordable as possible. So, Stephanie, has anybody asked any questions? I'll take a few questions for 5 or 10 minutes or so.
Awesome. Yeah, we have a couple here. Starting out, here's one from Sam. As I'm learning to manage my animals to create the disturbances I want, most mistakes are recoverable with enough rest. Can you think of any management-created disturbance on a farm that would do long-term damage to a piece of land?
Well, yeah, let's first of all, I think what it would be is by holding the intellectual concept called a mistake. What there is there's feedback. There is feedback, and what we do is we observe what happened. We see how the system is reacting or responding, and then we make a decision. Do we do that again, or do we do something different? So let's get rid of that idea of mistake. There's no mistakes, it's just feedback. Is there anything that you could do that would be totally drastic? Well, do you want to do anything that's going to like really degrade your resource base? If we think holistic management, one of our goals is to not degrade this resource base. We want to always aggregate it. Once we hit this, there'll be a site capacity where we cannot get any more productive than it is. Then we want to be able to maintain it there somehow. And sometimes what it might take, this particular pine stand right here, once these pines get bigger, we might actually choose to clear cut. Well, longleaf pine and loblolly pine, they require bare exposed soil to sprout. So how are we going to expose that soil? Well, we might choose at that time to rip up all the saw palmetto instead of just harvesting it annually, and then run through there with hydro-wax, set deep to scarify the mineral soil, clear cut the whole darn thing. All the seeds fall off of the trees. A lot of the cones are called serotinous cones, and they only open when they're burned by fire, and then burn it with fire. That sounds pretty extreme, doesn't it? What we did is we ground up everything on the ground. We ripped all the saw palmetto out of the ground. We ground everything up with the hydro-wax. We clear cut the trees. Then we hauled all that organic matter away. Then we burned it. That might be the best thing for the site for regeneration. That's one choice that we can do. So is there anything that would do that would like totally ruin the land forever without long enough rest? Well, if you pave it, you won't be able to get enough rest to farm it again in the future. Or you could blow a volcano up on it. What could get worse than blowing up a volcano? So part of what I wanted to point out here is there's no right or wrong. There are disturbances. We want to understand what is the disturbance, what is the effect. So how does this disturbance work? What is the effect on the landscape? How does this ecosystem respond and recover from that? How can we work with that pattern right there? That understanding that pattern is critical to being able to ecologically manage your property. And I'm sticking with that answer. Got a few more.
I love it. Here's another question we have. It says, I recall Mark mentioning before that all the diseases will show up on my site unless all the neighbors are doing the same thing I am. I have 5 acres, keyline designed, and there's conventional chem ag monoculture fields around me. Do I have a chance of having a healthy ecosystem?
You do have a chance of having a healthy ecosystem. We'll want to be careful about the word healthy for one, but for two is understand your site conditions. You've got 5 acres. Pest and disease cycles, plant life cycles, animal life cycles all have different, if you've got these little wavelengths, they all have different period of time, a different periodicity before they settle into some sort of a balance. With 5 acres surrounded by chem ag, you have different conditions than this guy does here. This is a 100-acre site surrounded by industrial forest land. So once every 35 years, a helicopter goes over after the clear cut and sprays everything with herbicide. So it's a very minimal input on that side. I'm surrounded by conventional corn and beans everywhere. 5 acres, if you create a diverse system on those 5 acres, all the pests and diseases that like those plants and animals will show up. You may not have enough critical mass of, hazelnuts or chestnuts or cattle or pigs or cucumbers, whatever it is, to have enough to satisfy the pests and diseases so that you have surplus, genuine ecological surplus to harvest for yourself. You may not be able to do that with zero inputs on a smaller site. This is an ecological reality that the larger the landscape scale, if we're talking like bark beetle in the Colorado Rockies, it might be 5 states is finally big enough to control this outbreak of a pest or a disease. So all these different pests and diseases and animals and plants have different scales at which they all of a sudden will click and function really ecologically smoothly. The smaller the site, the more likely you are to have some sort of input necessary. Now, when you do that input, you go read somebody's book that says, oh yeah, you do every 5 days, you spray this, spray that, spray this, spray that. Or do you observe your system? You observe all of a sudden, I've got, emergence of codling moth. Well, how many are there? Can I trap them? Can I, use some kind of distraction spray? Can I use a trap crop? All these other different strategies come into play. As restoration agriculture people, we have all of those options at our disposal. Everything from nuclear weapons and chemical agriculture with GMOs, all the way over to 100% absolutely natural wild stone tools and sticks. That is our toolbox. I stay away from the nuclear weapons and chemical side of things as much as I can. I try to approach the natural side of things as much as possible, and the scale, the size of the planting does affect the amount of control inputs that you'll have to put into place.
Sounds good. I'll throw out one more question for you, and then we'll wrap
We'll sell you some. We got a whole bunch for sale right down the road from us. Come on down.
Last question from Scott, asking about pigs. Even though they are not herd animals, can you elaborate on the disturbance that they give? And also, can you mob graze them?
Well, that's absolutely not true that they're not herding animals. You put them together and they all stick together. They are a herd. They're a herd animal. They don't necessarily have as large a herds as wildebeest or cattle, for example, or Cape buffalo, but they do herd. Their disturbance, you look, was it one webinar ago, 2 webinars ago, they have hoof impact. Their hoof impact is dramatically different than cattle. It's a sharper, pointier. They may actually, in some cases, have more hoof impact, per square inch because it's such a small hoof that they're on. They do a lot of the rooting and the plowing. We minimize that with rings in their noses, but you can go ahead and use that as part of your system. And even with rings in their noses, they still do a little bit of rooting and plowing. What I've noticed with pigs, though, is once they hit around 20, they start to break apart into a couple different clans. And there's only been like 3 or 4 times that we've had more than 20 pigs in the past 21 years. And every time we've had somewhere around 20, it's like you lose this little herd mentality in this one gang. And like over in Africa, observing warthogs, you rarely see more than 2 or 3 females with all their little kids and a couple of boys running around with them. So there's only about 15, 20, 30 of them in a herd. Can you mob graze them? Yes, you can. They have to be trained ahead of time a little bit more carefully than cattle do, in my experience. So you have a nice hot fence, you put them in a tight enclosed area. We do a double strand electric with metal mesh fence around it until they're accustomed to that. And then you put them out in a bigger enclosure and a bigger enclosure and a bigger enclosure. Through the years, there's been a couple times we really try to push it and really move the pigs around. I haven't noticed any additional gains or quality differences with really pushing their rotation, and they are, in my experience, a little bit lighter on the landscape than cattle are, because cattle, they'll really shred trees, where the pigs don't even bother the trees at all. So they're just different. And so observe pigs, the herding animals, pigs, how they disturb things. Of course, they're going to make a wallow because they can't sweat. They'll always make a wallow or a dust bath, depending on the circumstances. They'll oftentimes make a wallow by urinating in the same place over and over again. I tried limiting their water once because in a particular summer they kept spilling their water and they made a wallow where I didn't want it. So I would only give them enough water that they could drink right away, and then it'd be a little bit on the thirsty side. So then they all went urinated in the same spot in order to make a wallow. And I figured that's pretty gross wallowing in your own pee, might as well provide you with some water. It's probably, I don't know what else is going on. It was just gross. So I think I rambled around that question, but part of what was disturbance, pigs, herding animals. I think I addressed that. Did I get everything, all the points in your question?
Yep, you hit all of them.
All right, and I've got to go. I've got to go to a meeting next. I will continue with this next week. This is about 2/3 of the way through the presentation. Thank you everybody for being here, and if you find any value in this, please be sure to go back. If you haven't seen all of these live, go back and listen to the recordings as they're posted. And hope to see you next time. Thank you, everybody.